Good morning. Wow. I hope you all had your morning coffee and that you're sharp, right? Who's not sharp at this point? Because we're gonna battle. I mean, I'm taking the red corner, Pauline is gonna take the blue corner, and we need somebody to be judge and jury. Not the executioner part, just judge and jury. And, well, we have a lot of people over here, so you will be the judge and the jury. And at the end, we want an outcome from you. So pay attention, look at the arguments, and, well, pick your winner. And not because blue is a nicer color than red, but because of arguments, right? Because we're going to talk about Kotlin versus Java. I mean, two languages, one I think is more of a hype train than the other, but that's my opinion. So you know already that I will pick the red corner, Java. Pauline, however, will take the other corner and will, well, advocate for Kotlin. So, but first let us introduce ourselves, because many people like, who are you to judge, right? So, Pauline, go ahead.
Welcome, I'm Paulien van Alst. I'm software engineer at Open Value, and today I'm going to convince you that Kotlin is the better one.
Well, short and sharp.
Yeah.
Like Kotlin, right?
Kotlin.
Well, I'm Brian. I'm a developer advocate for Sneak, which is, well, by default, a security tooling company. We're not going to talk about security. We're going to talk about language features, and I will advocate the Java part. So from that point of view, we're both developers. We both did both Java and Kotlin. And I will start with the first round. This talk will consist of 6 rounds. In the middle, we want one intermediate vote, like how are the odds? How do we stand? So I want you to pay attention. And my first round is not about bread. Now, who knows where YAML stands for? Yet another markup language. Well, if you strike the M away, I would say Kotlin is yet another language. Really? Come on. We had a couple of them. And how did that turn out? I mean, we had Scala, we had Groovy, and they were all awesome at a certain point. And people started implementing them. I mean, Scala was like, oh, now we could do like real functional. And after 3 years, people turned back from Scala because, well, we couldn't find any Scala programmers, but we had a bunch of Java programmers. Let's convert back. Good choice. Still, who uses Scala now? Who loves Scala? See, 3 people. Who uses Groovy? And you use Groovy because you're programming Groovy or because of Gradle? Who uses Groovy as a pure programming language? Bam, made my point. Right? So the point is, how valuable are these languages, although they might be good? If we look at a skill, I know it's a bit small, but at the top 2, the last couple of years, there were 2 languages to battle. It was JavaScript or Java. And it doesn't matter what you think of JavaScript, because I think it's crap, but we still need to use it though. But they were there on top, and they will stay on top, and there's a lot of people there that are working with that. You know where Kotlin stands? Right one, lowest one, just came in this year. I know it's a young language, but yeah, Scala is somewhere in the bottom half. Groovy is somewhere there, but even PHP is higher. So you have a better job of doing PHP than doing Kotlin. If you look at the amount of jobs where Java is in, what gives you job stability? We're in Java. These are just numbers from the US, but just to make a point. And if I was a project manager or a project owner or somebody who advocates for a certain program, I don't care what language it is. But I want that my project will be continuous, that we can keep developing, and not that some consultant who thought that Go was cool and just turned away, and now somebody else has to maintain that crap. Same holds for Kotlin. If you want continuous delivery, continuous development, I would say go for Java. Because Kotlin is just syntactic sugar. You know these nuts with that glassy layer of sugar around it? It may taste sweet, but on the inside it's still a nut. And Kotlin, at the point, converts back to Java 8 bytecode. So, what's the problem? Staying on Java 8 or, well, I'll come back to that. So why Kotlin? Why should you use Kotlin? I mean, it can be fun and say for the sake of learning new programming languages, Learn a real language? No, but if you want to do functional programming, start with Haskell or something. Or if you want to do something else, choose another ecosystem. Because I don't think Kotlin is worth working in an enterprise environment. Although it has good ideas, I'm not battling that. But if you want stability in your project, I would say stay at Java. But some people might disagree, right?
Totally disagree on that. Very easy to show those figures about Java that exist now for 24 years, and Kotlin is only coming up. So give us a chance. Why Kotlin? Because Kotlin is just not another GVM language. They started on the GVM to get people over to Kotlin. But they have a big ambition to go to Kotlin native. And they are becoming an independent language on their own. And that's not all of it. It's just the best of all worlds together. Because the people that develop Kotlin are very aware of the Scala and Groovy effect. They have been living in this world. So Kotlin is based on the other ones. They had a look at Scala, they had a look at Groovy. So if you're going to learn Kotlin now and you already know Groovy and Scala, you will recognize some things. It will look familiar. But the developers of Kotlin learn from the mistakes of the others. So the long compile time that you know from Scala, you won't recognize that in Kotlin. Or the loosey typing of Groovy, that's all fixed in Kotlin as well. And it has been so nice to develop in Kotlin that it has been adopted as official Android language as of 2017. That means that big companies like Google, JetBrains, are standing behind that language, Brian. So you can show me those figures, but those are pretty big names in the field. And when we look at the developer survey of JetBrains, where they ask some questions to developers who are using Kotlin, on where they're using it, you will see that it's not only used in mobile applications, but also in backend services, and it's used in libraries, and even in the front end. So, yeah, I think more people than Android developers are using it. It's not just another JVM language. Second round, Brian. Less is more. Java is very well known for all its boilerplate code, and if you're using pure Java code, you have to write a lot of getters and setters and whatever methods to make your code clean and working. But with Kotlin, we don't have that problem. You can just define a nice data class in one line, as you can state it here, where in one line I can generate for myself a constructor, but also a hashcode method, a toString method, a equals method, and a copy method, because we like immutability in Kotlin. And this all without any help of third-party libraries. Of course, I can do this in Java as well, but I have to use a third-party library such as Lombok, which means more maintenance, and I don't like maintenance, and my product owner doesn't like maintenance, because that's stories without business value. Why stating the obvious? With Java, we are spending our time stating the obvious. So when I'm declaring a variable string and instantiating it to a value that is a string, I still need to declare the type in Java, or at least until now. Well, in Kotlin that's not needed. We can just forget about it. The compiler will do its work. We live in a world of data, right? Big data is a big buzzword. So we're working with a lot of collections as well. So in Kotlin, we can just, in an elegant way, instantiate our collections with some nice utility methods, again, not from third-party libraries. And instantiating a map in Kotlin is also more readable. I can finally use those keywords that I'm known from our common languages. So this looks way better than this kind of code. Certainly is Java 8 code, but we're still remaining on Java 8 because it's so, we're not moving, we're not updating to other code. So this is much less readable. And last but not least, in Kotlin, you don't need to use the terminator operator ever again. You can just finish your line of code and the compiler will take care of it. So yes, code should just be efficient to write, but also to read. And that is enabled in Kotlin. How about Java?
All right. Fair points. But stating numbers like JetBrains investigated what JetBrains is like. Coca-Cola says that Coca-Cola Light doesn't contain any parts that are harmful for you, right? But you say code needs to be effective to write and efficient to read, or the other way around, but both writing and reading, right? From the reading point of view, I totally agree, but it doesn't need to be easy to read, it has to be understandable. That's the whole point, because I write code, and I have people that need to maintain that crap, because, well, I write crappy code sometimes. But you write awesome code, I know. The point is that verbosity doesn't necessarily mean that it's less readable, maybe sometimes even more readable, but that's up to you. And if you talk about writing, what's better than not writing code and let the IDE generate it for you? So what's the point in that? I mean, I've got an IDE. Who works with VI or with Notepad? Nobody. You, sir, you're my hero. You're like the die-hardcore programmer that uses just a text editor. No, but seriously, we use intelligent development environments. Why? Because we can do dot, and then it does something for you. You could do tap or whatever, and it helps you, right? So, but let me go to that point of what do we need? I mean, yes, out of the blue it can magically do something in Kotlin. If you want to do that, fine by me. I'm all cool with that. But first we have to look at what do you need. Maybe I don't need a toString. Maybe I don't need a copy constructor. Maybe, well, again, it's up to me, right? And if I want to do these things, yes, I have to introduce something like Lombok. But how bad is this? Every single application uses third-party libraries, even Kotlin. I mean, every Kotlin thing has to be brought somewhere, or use Spring Boot. Wow, Spring Boot downloads the whole world. So, first thing, is verbosity that bad? And what do you need in an object? I mean, if we have a Java object like this, and I put 3 annotations on it, because I only want getters, no setters. I only want an all-args constructor and no, like, normal constructor. And I do want a toString. Is that bad? And don't get me started on that reflection part, because everybody uses Spring, right? But take it a step further. If we create DTOs, data transfer objects, do we actually need getters and setters because we need to do private things? Why not just public accessible method if it's only transferring data? And now I see some question marks like people. What's different between making a private thing and then a getter and a setter? In my point, nothing. And if you want to make your code concise, you could do this. But let me get that further. What is the problem? The problem is that we're still on Java 8. I mean, you see the red thing, right? 2017. Java 9 came out. And we have this nice off methods that we can create a list out of the blue without doing that ugly arrays.list. By the way, if you want to do that in Java in a one-liner, you can do stream dot. You can use stream operators to do so as well and collect it into a list if you want to do it in a one-liner. But in Java 9, we introduced something like this. Even more, Java 10, March 2018. Come on, people. We're like on the bleeding edge. We want to do everything, but we're still on Java 8. In March 28, we had local type inferencing. Local variable type inferencing. And we can do vars, yay. So stating the obvious. But even more, if you keep continuing, last LTS, because people were like, yeah, there are intermediate versions, let's wait for the LTS. Last LTS, September 2018. We could do things like enhanced switch statements. So if you want to write less and be more readable, I would say just upgrade and not switch to another language, because maintainability. If you do Java, you can still do it in the old way, old-fashioned way, but you have the ability to do it in a newer, more concise way, if you want to. But still, that's up to you, your team process. Let's go to the third round. Because, are you still awake? In the meantime, I just want to know one thing. Who is a Kotlin developer? Okay, who tried Kotlin in his project? Who wants to try Kotlin in his project? Who is like, stay to Java, man. Well, I've got some I need to convince some people though. But round 3, I'm going to talk about structure. Because what you can say about Java, it has a very strict structure, right? And structure is good because, well, not because of my kind of thinking, and I like to structure everything. But in general, because we want to have clear code, clean code, we want it to be organized and we want it to be consistent. Why? Because people move in and out of the teams. If new people come in and I need to write 3 different code styles, it's horrible. And you have to explain it. Why did you do it like this here and that there? Well, at least in Java, we have some structure built in that language. And, well, it's maybe kind of strict, but it's obvious. And I like it. If we have a class in Java, everything lives inside a class in Java. Every function, every method lives inside a class or has to be declared inside a class. We've got fields, part of a class. We have a constructor, part of a class. We have a method, part of a class. And if we want to access that method without making a new instance of a class, we make a static method inside of a class. Because we don't write code for machines, we write code for people. So I know where the stuff is. And that's very convenient because I like structure and I like the type system because it helps me not make that many mistakes. In Kotlin, you can do something like this. Does this make your code more or less readable? I will give you a moment to think about that. Yes, we can do the any type, and we have the object in Java as well. But if you want to do something like this, at least you have to do costing, and you see it's nasty. But now this is out of the blue supported in Kotlin. Cool. No. So, but more about structure. Let me dive into Kotlin a tiny bit. We have this, in my opinion, awful things like extension functions. And although I understand why they do this, we can do things like this. So I have this main thing, doesn't need to be in a class or something, but okay, fair enough. And somewhere I can define a function that works on a string. But if I see string.function or my own object.function, I believe it has to live inside that domain entity. Or else it has to be declared as a normal function in that class, because now I know where it is. In this case, it's pretty obvious because it's right above. But I can declare everything like this in every single function and just import it. So I have to look through my imports where it is. And don't give me that argument to my IDE will help me, because we just saw that Rabobank, for instance, will use a stash to do their code reviews, right? How do you clickety-click in stash? Or do that in GitHub or in GitLab View or a diff editor, because that's the most thing we use to do code reviews. And I think that code should be readable and we should not depend heavily on an IDE. Although most of you probably use JetBrains IDE thingy, and it works out of the blue, maybe some other people don't. So, structure. What about you?
Indeed, structure, Brian. Structure is very important. So I totally agree with you on that point. And Kotlin makes it even easier for me to structure my code. Because, for instance, when I'm describing my domain, my functional domain, in Java I have to declare one class per file, which forces me exactly to have my structure, but also it limits myself to that one file for that one class. But sometimes domains are not that easy, right? Modeling the world around us is a very difficult part of our job. So if I want to describe a person who lives at a certain address with a certain zip code, I want to model that entity using several classes to structure my code a bit and to avoid very big constructors. This example, I can declare all those classes in just one file and make it very clear to my colleagues as code should be readable and maintainable, that those three classes, those three entities belong together at each and every point of time. So, and I can set some rules on those things. So that's really, really nice. Other thing is inheritance, for instance. That's a very common used thing in Java, and we also abuse that in Java a lot. And in Kotlin, we can restrain our users finally with that. For instance, a class is always final, so I can't inherit by default from my classes. But as a developer, I can say, okay, I can inherit from this class, but only in this certain file. I can do that by adding the sealed keyword. So that means that this parent class can only have specific childs that are declared in the same file. But if I don't care about my inheritance and that I'm fine with everyone inheriting my class, I can just open it with the keyword open. So when I'm writing my APIs or my classes, I'm fully in control of what's happening next. And I'm fully in control on the message that I leave to my colleagues maintaining my code base. So yeah, structure. Kotlin has all the things that you mentioned and has some downsides, but it has also some other very big advantages. We're halfway our battle, so...
Yeah, it's round 3, and we said we do only 6 rounds.
Yeah.
But we can go for ages, though. I don't think we'll ever stop rambling about this. But we have a halftime report, and just like every halftime, we want to set the score. So how far are we in? First of all, I want some hands for who is more in favor of Paulien. Okay, now I'm wondering if the rest is still sleeping or are in favor of me. Who is in favor of me?
Okay, have some work to do, some work to do.
But we're only halfway. We're only halfway. That means we've got half of the things to go. And, well, as it turns out, normally if I start the first half, right, the other party should start the second half. So, well, I give this opportunity to you to talk about, well, whatever you think is good.
Yeah. Well, you had about structure. Structure is so important in Java. We're so good at it in Java. But structure is not of any needs if it's not safe. And there is one thing in Java that's not safe. Really, Brian, do we really need nil? Is it very necessary to have objects that hold nothing? Really? Nah, we don't need it. So Kotlin started the whole intention to write a language without any nil. But then people started struggling with it because all our frameworks and our ecosystem really is in love with nil. If you write per Kotlin applications, your types will be non-nullable by default. So no null pointer exceptions whatsoever. If you want them, you can get them, but you won't have them by default. So that's really nice. You can't argue with that. But okay, let's tolerate the Java side. So Kotlin has a possibility to have nullable types. That's possible. We can have a class with an optional value where I can specify that my value is nullable, or have another class where my value is non-nullable without a question mark. So let's take this example. I instantiate my value with a nil. With nil, because sometimes we do that in Java. If in Java I evaluate the second statement, it will break, right? Null pointer exceptions all over the place. We are very common with that because sometimes it happens, and when it's happening in production, you feel really dumb. So in Kotlin, you can just use the Elvis operator, where you can say, okay, this can be null, but if it's nil, just evaluate the whole expression to nil, or do something else with the value. So, yeah, that's cool. But we have MPE lovers, apparently, Java developers. So sometimes we want to have a null pointer exception, and Kotlin can also deal with that because otherwise Java people won't come over to this side. So we just add 2 exclamation points, and then the whole thing will break into your face, and you feel very comfortable in your comfort zone of null pointer exceptions again. So no worry, you can come to our site without any problems. You still feel very comfortable. And as I mentioned in the first round, we have data classes. And those are nice because in one line, you can declare your model, your domain, and you can't forget about the following things. You will have a copy method because we are in love with immutability, so we copy our objects and then change some values. You will have an equals, a toString, a hash code. I don't know, when I started to work, I forgot about the toString and the hash code all the time, and it really made my days terrible. It can say something about me, but I think it's a good thing that that's safe, that's guaranteed by your language. And of course, getters, you don't have any setters, or at least you can have them, but that's not idiomatic Kotlin. And your constructor will be given to you as well. That slide shouldn't be in there, so I will just give you.
You give me a chance to defend myself.
Yeah.
I mean, I thought we would make it a clear and fair fight, right? Why hit me below the belt with that null thing? Come on, it hurts. It hurts.
It hurts?
It hurt. Yeah, it hurts.
That's
really
more
hurts.
of your problem.
So
than
I will not even go into that null thing because, well, I agree, and I'm not in love with no pointer exceptions. But okay, I'll give you that one. But again, I believe I work with clever people.
Oh. Lucky you.
So I hope we have clever people in the room. Wink. But let me tell you, who of you works on greenfield projects? Like real greenfield projects, new thing. We do not have to integrate with old stuff, making a SOAP request or Corba or whatever. Real greenfield project. I can do anything I want. How many? Hands, please. Sorry to say, but I think that greenfield projects are for pussies. Why? Because the hardest part is integrating with old stuff. Go into a project, we need to integrate with old stuff because it needs to run. I need to fix that aeroplane while it is flying because I can easily take it offline, rewrite it, and do it. It takes me 2 weeks, but as our main sponsor, Rabobank, would agree with me, I guess, yeah, getting off the transaction service for 2 weeks would not be convenient. And that's for most of for things, yeah, right? So most of the times we have to integrate with old projects. And then Kotlin can be very cool because it's interoperable with Java. But who has heard of these language, of these frameworks? I don't say I like them, but they manage my objects. That means, although we can be immutable by default, that doesn't work for Hibernate. That doesn't work for JPA, right? Because they change the state, they manage the stuff, they persist it again. And I don't have to think about it. Well, unless it goes wrong, but that's with everything. And if I want to use these things, I want to integrate with my old stuff because I need to. Guess what? I need to introduce third-party libraries. To make this work with Hibernate, make Kotlin work with Hibernate, you have to do this in Maven. So I have to introduce some stuff to make it work because, well, mutability. And although we can agree that immutable from an academic point of view is much better because we can argue about the code more structurally and we have less fuzz about what's stated in, this is reality. And there's a lot of things that you learn in university which is not applicable in reality. Like not wanting dependencies. We have to. And I mean, even if you do, okay, say we do this one time, perfect, fine, no worries. Then you have to write your Kotlin entities like this. Does it look any different than your Java things? I would say no, simply because I need to still do these awful annotations. Well, I don't think they're that awful, but you might disagree with me. So they look quite similar. So if I want to do Kotlin, I still have to do the same old crap. And face it, what we want to do in a programming language or in a program is, I think, simply want to model the real world, right? We want to model the real world so we do not have to do things by hand, so we can automate it. That's basically what we do in automation. We live in a world where state change is possible. If I have my bike, we're all Dutch. I had to explain this in Barcelona, that we all own bikes. We all have a bike, and I can pick up a spray paint can and paint it. So it's possible to change the color of my bike. I can buy a new one, but I don't know how your salary is, but every single week a new one. Really? And then last but not least, how many of you work with applications that need a lot of throughput? Like, say, thousands of requests, 10,000 of requests per second. If that is the case, yeah, see a few. If that is the case, immutability has one single problem. It creates a whole lot of garbage. Every object needs to be cleared. And we do not work in C, so we have to do, we let our garbage collector kick in, which is cool. But you know what the hardest problem is by making it perform very well? Is your garbage collector. Because at a certain point, your garbage collector kicks in, stops the whole world, cleans the shit up, and then eventually it has to start up again. And then you could say, yeah, well, we work in the cloud. Perfect. If you have a lot of money, fine by me. You spin up another thing and another thing, but eventually we need to cut that down. So we need to create a lot of garbage, and we need to gather that garbage to do so. If you are immutable by default, and that's the way you program, then you might have a problem with speed, with, well, I wouldn't say consistency, but the fact to make your throughput worthwhile. And again, I mean, let's talk about round 5. I'll stop about this. No, this is not me. No, this is not my cat. Yes, I am lazy. By default. That's why I use Java. Because we can do this in Java, right? Like we can, Java 9, we can create a list of something, and then we can map. If we use a stream API, we can use these nice higher order functions they created, like map and filter and whatever. Pretty cool. Well, if you say, oh, this is too much thing, we can write it like this for the Java, for the people that say, too much stuff. So we have this, we can do this, and then the people of Kotlin said, cool, but we can do this higher order functions directly on a list. Look, cool, right? Without doing the stream operator, we can do the higher order functions on a list, so less boilerplate. Okay, we're going to argue about one word. Perfect. But is that true? Do you think that's true? Well, you're right, because you know what's coming up, right? If you evaluate this, and this one, I mean the lambdas or the functions inside these higher order functions are ugly because they do a side effect. They print something, but it gives you some insights. Is it what you expected? Every single result first goes to the map function, and afterwards it goes into the filter function. That means that every single result will be held inside your heap, or will be memorized, before going on. And what we read is, we have a list, and we go to step 1, step 2, step 3, step 4, and we have an IKEA closet. Right? We think about every single one goes to every single piped value separate. But no, we still do the first one and then do the second one. And that's because lists in Kotlin, just like in Java, are eager. If we want to do the same thing in Kotlin as the stream API does in Java, we have to do another keyword, the S sequence, which makes the things lazy. At that point, we can have a map filter, map filter, map filter, map filter, as we expect it, as we read the code. And yes, so that's because we have to be backwards compatible, because we want to support everybody and not exclude personnel. We do that in Java by default. So if you have the same code snippet in Java, and it's ugly, trust me, because I do, again, I do something extra inside a Lambda, which you should never do, but just to make a point. You see that it is lazy by default, and this is more, well, I wouldn't say convenient, but what you expect if you read the code. So there is a distinguishment between. So you're actually comparing apples against oranges, or how do you say it in the Dutch? Appels en peren met elkaar vergelijken, or whatever. And even more, it has a penalty. If we look at lists in Kotlin and we just use it because who cares? Eventually it is consistent, right? If we do a sum of a list of, well, 5 million numbers, and we measure how long it takes for a map inside a list to sum everything up, it takes over 14 seconds. While a sequence, the lazy one in Kotlin, takes just 2 seconds, 2.07. If you want to calculate the average over that enormous list, again, in a normal list, you should do that. You shouldn't do that because, well, it takes about 11 seconds, 11.4. In the sequence, it takes 3.2 seconds. So that means we have to be careful not to just one-to-one translate something to Kotlin if you want to use it. We have to be sure that we know what we're doing. And it is not obvious in Kotlin. Now I told you, and now you're safe. I know, thank you for that. No worries, you're welcome. But make sure that you know this, because your code and your tests will run. But it will increase something, and you thought, well, I just implemented Kotlin. It can be fast, right? Know what you're doing. And that's obvious in Java, because, well, that's why we did the Stream API. But I'm lazy. I'm just giving you you a fair try.
Fair point. Fair point. Who of you known this difference in Java? Who of you known that streams work this way? Okay, so you did your homework.
Smart people.
Yeah, smart people. You're working with smart people. That's really obvious. Java developers are smart, apparently. But we did our homework as well. We do have the choice in Kotlin. Indeed, a list, as we know them, have the same API as streams, that's for sure. So if I want to have a list of doors, I can instantiate them like this, and those are not lazy. Of course, I can have lazy evaluation to cast them to a sequence like this, which again is some extra typing, and it's not feeling very useful if you compare it to the dot stream in Java. But let's be honest, when we're constructing a collection in Java, in whatever code base, we should think about what we are going to do with it and what kind of data manipulation we are going to do with it. So we can also instantiate it like this, right? So if we know that we are going to have a lot of data and we have to do a lot of data manipulation on it, we can just instantiate it as a sequence. And then we are fully aware of the fact of what we are going to do with our collection. So we are also smart people, and we also know what we are going to do. So we just instantiate our collection on how we want it to be. And then both of the type of collection will have the same API, so we're still feeling comfortable in what we're doing. So, point taken.
Final round?
Final round.
Oh, God.
Then again, we're living in a real world, right? And in real world, we have a lot of collections, as we already mentioned. And in our world, collections are a very important thing, as data in manys are very important. So in Kotlin, it's a bit easier to define behavior on collection level, finally. So, of course, again, we're going to instantiate a data class because we always start with a class in object-oriented code. But if we have a cat, we never have only one cat. In most of the problems, we have a lot of them. And if we want to know if we have a lot of cats, how many of them are adults, or only retrieve the one that are adults, for instance, you can define an extension function in a proper way like this. And I even can declare this in the same file as where I declared my class cat. That means that in one file I can declare the behavior as a class with its methods on the behavior of the single class, but I can also define the behavior of the collection of that class. So the example you gave us with extension methods, I will agree with you that that's really not nice. But this is the proper way to use it. So yes, you have to think about how you use it, but that's a common case. With every tools and every features you got, you have to think about how to use it. This is how you use extension functions. And this is where they're very, very useful. It avoids code duplication, it avoids mistakes, and it helps you to declare your API on a higher level. And this can be called like this, with just a cat.adults, which is also much more readable, and you can just show this code to your product owner or business analyst and talk in human readable words about your code. And that's not the only thing that you can do with collection. You can also overload your operators. Finally, when you're working with Java and numbers, you have this big decimal class where you can chain all your .add, your .minus, your times functions, and you can't even remember the whole operations going on. Kotlin, you can add cats using just a plus sign as we're used to from primary school. And you know what? That's even mathematical responsible. It's just how we do in mathematical world. So why shouldn't we do that? Come on, people. That's how we have been taught at school. And then there's another part in our work that's very, very important, and that's writing tests. We write tests for ourselves when we're developing. We write tests for our colleagues to describe the functionality that's implemented. But we also write tests to describe the functionality to our business analysts and product owners, so we have a common language to talk with it. Finally, I can do that in Kotlin. I can write my own DSL that when given my test scenario, when Kotlin is better than Java because it is, then Kotlin wins at the end. I can show this test case to my product owner, talk with him about it, and then we can discuss if it is a good test scenario. Again, without third-party libraries, which I still don't like to maintain. So yeah, now this test scenario has been written. I'm curious about your final argument.
All right, so you try to influence people by code, saying Kotlin is better than Java. Well, let them decide, because I just don't say behavior on languages, but I want to talk about that behavior part in general. If you see this code in Kotlin, and I created my own class foo, which contains only a string, I make two instances of it, AAA and BBB. Everybody knows what it is, right? No, that's the whole point. What is A plus B? Because, well, although we can mathematically decide for ourselves, if we read something, we have an idea about something. And if code must be readable and not a guessing game. So what do you think A plus B is? Is that foo AAA BBB? Or what is it? Because at this point, you are not able to see the imports. And there is no plus operator defined on the data class, because the data class is over there. So it can be in one of the imports, right? We simply have no clue. It can be, again, because it's the same as an extension function, it can be everywhere. So although we can do this, we do not know, like, instantly what it means. And I think, again, it should be clear. So you know why the reason we cannot do operator overloading in Java? Because it is simply not clear. We can do everything with it because we can overload everything. That's why it's not possible in Java. This is not possible. Well, that's why the strike through, right? In Java, you cannot add two classes that you created your own with a plus operator, which is fair. We come to arguments later. Let me do my argument first. Yes, I know. I'm being dogmatic. But the point I want to take there, but this is how James created the language at first. That was the meaning of it. So normally you cannot do this. Yes, we can do all sorts of nasty things, also with reflection and whatever you want to do. Doesn't matter. If we go to Kotlin and have the same code, and I'll have this import. Again, what is the outcome of A plus B? Because you see, I just imported some funky util that is in somewhere in an example, whatever, and I can do something. But you have an expectation on that plus. But if I run it, it has the value funky. Is that what you expected when you saw a plus sign? Who expects that? Nobody. Because I think if you should do operator overloading, you should do that in the declaration of the class. Then I'm okay with that. But still, it's harmful, because code should be readable, code should be understandable, and code should not be a freaking guessing game. So, although we can do this, and it might be useful in some places. I think by not allowing this, code will be more useful, because if we want to concatenate two strings with each other with a plus, I'm fine, thanks for that. If you want to call two numbers together and add them together, it's fine. We all know what it means. But if you want to do add two of your own classes together, nobody knows what you means. Although it can be, well, kind of implicit, you don't know for sure what it means. But that will be my final argument, because we can ramble on and on and on and on. And finally, we have to have one winner to rule them all. So, I hope you're still awake. I hope you heard all the arguments. And I hope you give both of us a fair chance to win. So I want to see some hands. And you can only vote one time, and you only can vote with one hand. And some people are like, yeah, no. One hand, one time. And I trust you, because you're a fair judge, you're a fair jury, and we will not do the executioning part. So, hands for Java. All right, fair, thank you. I appreciate it. But then, I mean, it's still young, you have time. Hands for Kotlin. That's a fair amount.
That's a fair amount.
To be honest, it's a fair amount.
Fair.
And I think we have to conclude with something, because although we are very dogmatic in this talk, right? We are using the most worst examples we can ever try. And we can now say, as consultants, it depends. But it's more of like, know your language. And that's the real part. Know what you're doing, and not just implementing and copy-pasting from Stack Overflow. Because although it might work, you have to know what you're doing. For instance, these overloading kind of things and these extension functions, they can be useful if you do it in a nice way. But you have to work, and you have to see that if you can work that out with your team culture, and your process. So, some people might stay with Java, and Java has some good points, and I want to say, please upgrade. Yeah, because staying on Java 8 can be convenient, but now I'm still wondering if I do this talk a year from now, ask this question a year from now. Let me question it now. Who's on Java 8 in production? I hope a year from now, most of them say I'm at 11 or 10 or 12 or whatever because of the policy kind of thing. But there are increasements, there are improvements in all these languages. And by not going, you can go to another language, but is that just to conceal the fact that you do not want to upgrade? Is that the right reason? Think about it, don't answer it.
Yeah. And don't only think about your language and your technology stack, also think about the people around you. Is your team able to switch to another language? It's not that obvious. Kotlin has their own idioms, and your team should understand that. And it should be possible to hand over the code base to other teams in the company. So it's not that obvious. I'm not that dogmatic as well. Sometimes it's better to stick at Java, and sometimes it's really, really nice and comfortable to switch to Kotlin.
I will do what I ever say, give it a try and try it in your own projects, but not convert like your new microservice. Just because we can do it in Kotlin or do it in whatever language, make sure you can maintain it. You can keep it concise, and you can maintain it. We want to give you some room for questions. We got a few minutes left, I think 3 or something. These are our names. These are our Twitter handles. We will be around here all day. If you have questions you do not want to ask now because you're pro Kotlin, no. Because you're not
feel comfortable to ask them.
You feel comfortable to talk to us. We did both projects in Kotlin and in Java, so we can say a fair amount of it. But are there any questions now, or commands, or any things you want to say? Like, you suck, is probably. Yes?
I was wondering, are there things about Java that you don't like, and are there things about
A lot.
Yeah, a lot.
A lot.
It's not that black and white.
It's not. For instance, I totally agree with the null thing, but it's historical. So yeah, we can get rid of that, but then we break probably half the world. There are other things, and I think they're trying to improve with that, because, for instance, multi-line strings is something I wanted for ages, and it's not that. I would say it's not that hard, but if you talk to the architects, it's low-hanging fruit, but they still need to implement it, and they will do that. So we need to upgrade. But yeah, there are a few things that I don't like, and I think you agree with that in Kotlin.
Yeah, I agree with that in Kotlin as well. The example about the extension function that Brian gave you, I gave that example to him. I think that's I helped him out with that. had to do to had some. No, but that's a very ugly example. If you can change behavior of those classes in such an easy way, it shouldn't be possible. But I think there is a responsibility of the community at any times to teach that to one another, because the feature has some very valuable things. So yeah.
Yeah, so to quote one of my favorite Marvel things, with great power comes great responsibility, right?
Yeah.
No, but it's true. You can do awful things with both languages, but you should be aware of what you're doing. So our time is up. If you have questions, come up later. And for now, I want to thank you and wish you a very, very nice conference. Thank you.
Thank you.